We're going to talk about how to classify real numbers. Pretty much every number we're going to talk about this year in Algebra 1 is a real number. When you get into Algebra 2, we'll start talking about some imaginary numbers. But for now, everything that we talk about is a real number. Every single one of these numbers that you see down here along the bottom is real. Now I have to decide, are they rational, irrational, integers, whole numbers, or natural numbers? To be able to decide which category I need to fit them into or put them in, I probably need to know the definitions of each of these words. So if you look here, I've got this written out for you. My natural numbers are my counting numbers. If you think back to elementary school, when you started counting, your parents probably didn't teach you to count 0, 1, 2. Everybody starts with 1. 1, 2, 3, 4, 5, 6, and so on. Those are our counting numbers. Those are natural numbers. They do not include 0. It's what you naturally learn to count by is how I think of it. 1, 2, 3, 4, and 5. Those are my natural numbers. Now the whole number, it's all of the natural numbers, but now we're including 0. And I think donut hole, whole numbers, I've got that donut hole which looks like a 0. So maybe that'll help you, maybe not, I don't know, but that's what I think of. So my natural numbers, those are the numbers I naturally learn to count by. The whole numbers are those natural numbers and the donut hole, the 0. Okay, integers are just whole numbers and their opposites. Well, we know the opposite of 1 is -1. The opposite, I should have wrote that on the other way, kind of like we would on a number line. So the opposite of 1 is -1. The opposite of 2 is -2. So I've got all the whole numbers, so I know I've got to have my donut hole in there. And now they're opposites too. -1, -2, -3, -4, and it just keeps on going. So my integers are the whole numbers and their opposites. Rational numbers are numbers that can be written as decimals, but they have to be decimals that terminate. If you think about the Terminator, what does he do? He ends people's lives. So terminating means I end. There's just one number after the decimal point, 3.2. This comes to an end, so it's a terminating decimal. Or a rational number could be expressed as a repeating decimal, 1, 2, 3, 1, 2, 3, 1, 2, 3. It's repeating in a pattern. See the pattern here? 1, 2, 3, 1, 2, 3, 1, 2, 3. Anything that can be written as a fraction is a rational number. 3.2 could be rewritten as a fraction. It's 3 2/10. 3.123, repeating, that could be expressed as a fraction. I don't know what it is right off the top of my head, but it could be written as a fraction. And the difference between rational and irrational is the rational decimals either end or have a repeating pattern. Irrational numbers are non-ending, non-repeating decimals, such as pi, that's 3.145, I don't know what it is, 3.14, and then it just keeps on going, but there's no repeating pattern. Pi doesn't have a pattern, it doesn't repeat, it doesn't end, it's 3.141592654, and it just keeps on going, keeps on going, keeps on going, never repeating. So it's an irrational number. The square root of 2, it doesn't end, it doesn't repeat. It's 1.41421356, and it just keeps on going, doesn't end, doesn't repeat. Okay, so let's go back to that original picture that I had here. Let's look at the number 1. Well, 1 is going to go into several different categories. It's a natural number. Well, we know that natural numbers, or whole numbers, are just the natural numbers, and then they include 0. So integers are the whole numbers and their opposites. So if 1's a natural number, it's also a whole number, and it's also an integer. So 1 is a natural number, it is a whole number, it is an integer, it is a rational number, and of course it's a real number. Notice if you're in this column down here, that actually puts you in every other column. This is a Venn diagram of sorts. We've got the whole numbers, the natural numbers are inside of them. The natural number is also inside of the integers. The natural numbers is also included in the rational numbers. So if you're a natural number, then you're going to fall into every single category. Looking at the number 0. Okay, 0 is not a natural number. We don't naturally count 0, but it is a whole number. If it's a whole number, then it's also an integer, a rational number, and of course a real number. And I really don't need to write it. I'm being repetitive writing it in each little circle because the rational numbers include this circle of integers, which includes the whole numbers. So once I write it in here, that includes it in the integers and the rational numbers. If I look at -8, -8 is an integer because we know that negative numbers, the integers include the whole numbers and their opposites, and -8 is the opposite of 8. So it's an integer, which is also a rational number. 3/4. Since it can be written as a fraction, I know it's a rational number. 3 is going to be a natural number. It's one of the numbers I naturally learned to count by. Therefore, it's going to also be a whole number, an integer, and a rational number. 7.2, repeating. Since it has a repeating pattern, I know that it is rational. 2, 2, 2, 2, 2. It keeps on going. So it's a rational number. 6.45, it ends. It's a decimal that ends, so it's going to be rational. Square root of 3 and pi, if you type those into your calculator, they don't end. They're decimals that just keep on going, and there's no pattern. So I've got the square root of 3 and pi are irrational numbers, and they are also real numbers. Then 11/5, it's already expressed as a fraction, so it's easy. I know that it is a rational number.